So in this exercise, we're asked to utilize the tools that we have, Ohm's law and such, to to determine what the value of this resistor R is. We are given the fact that it has a 30-volt drop across it, and so we're going to use that piece of knowledge, but we also have the value of all the other resistors in the circuit, and also that there is a 15 amp current source in the circuit as well. So let's see how we would go about approaching this. So the first thing we want to notice is we have these two resistors here in parallel. So we can simplify this then by reducing those. So we see that we have 4 in parallel with 12. And so that would give us 4 times 12 over 4 plus 12. And when we work that out, it should be 3 ohms. 3 ohms. So that being the case, we should be able to replace that. So we won't need this anymore. And so we can replace it with one resistor here of 3 ohms. Oops, sorry. 3 ohms. Okay, so now we want to look at the fact that we have this current here defined as I, and we do know that we have a voltage drop here of 30 volts. So if we take that into account, we should be able to use Ohm's law then, right? So Ohm's law says that V equals to IR. So in this case, we can define I then, solving for I, as V over R. So in this case, it's 30 over R. So there's one piece of information that's useful. So another thing we can notice then is with this current source, as it comes along this path, we see that we have a current divider, and we know how to handle that. That's a standard equation to determine how the current is divided. So with that, we can also define I with that. So I is going to be equal to the source current, right, times the resistor that's not in the branch that we're interested in over R1 plus R2, which R2 is the one we are interested in. So in this case, that's going to be 15. That's our current source. 3 is the branch we're not interested in, so it's going to be 3. And then it's going to be over, again, the one we're not interested in, 3, plus our other branch here, which we know that is R plus 3 because they are in series. So we'll say R plus 3, right? And so that's going to be equal to 15 times 3 is 45. And we and we reduce in the bottom, that's going to be R plus 6. Okay, so now we should notice that we have two different expressions for I. Here we have I is equal to 30 over R, and here we have I is equal to 45 over R plus 6. So that being the case, we should be able to set those two equal to each other. So in other words, since let me rewrite it with the colors. We're going to say that I from the blue part is equal to I from the green part. So when we look at it that way, that means we're going to have 30 over R is equal to, and from the green part, we have 45 over R plus 6. Okay, from here, we can just cross multiply. So for this one, we have 45 times R, and that should be equal to this side, which is 30 times R plus 6. And so if we multiply that out, we'll have 45R is equal to 30R plus 180. Subtract 30R from both sides, we'll have 15R is equal to 180. And so now finally R is equal to 180 over 15, which we divide that out, and we get 12 ohms. So that is the answer to the question. R here is equal to 12 ohms.